All right, guys, this is lesson 4.2. This is part 2. And this is where it gets a little bit trickier, maybe a lot bit tricky as we get going in these. And so we'll kind of pick this up and go through it somewhat, at a nice pace. But if you need to watch it a second time, that might not be a bad idea. Okay, so we've talked about 4 different things you can do to your sine graph. You can change the amplitude, period, phase shift, vertical shift. So it makes sense that they will ask now for questions. Tell me about all 4 of these things. Amplitude, period, phase shift, vertical shift. And so let's look at our first equation. You can kind of see we've got a sine graph, but they put a 2 in front. They've got this minus pi attached inside the parentheses. So when you look at this, it's like, oh, thank goodness they're not doing 4 things. They're only doing 2 things. But what are those 2 things that they're doing? And let's look back now at our basics here for sine and cosine graphs. We got sine, we got cosine. It's the same forms. We had a number in front. Right there. What does that A stand for? Right there, it's the amplitude. We also had in a parenthesis a minus something. What does that number stand for? That stands for the phase shift. And the phase shift, remember, it's always the opposite of whatever sign they give you. So in our equation that they just gave us, we have 2 things. We've got the amplitude and we've got the phase shift going on. So let's look back at our equation again. So we've got 2 sine of x minus pi. So what is the amplitude of our graph? It is 2. What is the phase shift going to be? Well, it's going to be pi. We always take the opposite sign, so it's minus pi. That's going to be pi units to the right. Okay, it is very possible and probable that some of you can say, okay, I know what a sine graph looks like. I know how to up it, the amplitude up 2, down to negative 2, and how to shift it pi to the right. And you can do all this in your head. Or you can do it by drawing it and erasing it or whatever. And that's perfectly fine if you can do that. I'd like to show you another method that will also work, and it will work much better as the problems get more difficult. So even though you can do this particular one, without all this trouble, it's a nice process to know because as the problems get more difficult, you might rely on this process. So for this to work, you need to have in your head, off the top of your head, you need to know what a sine graph looks like, and you need to know what a cosine graph looks like. In the case we're doing right now, it's a sine graph. You will need to know your key points. When x is 0, pi halves pi, 3 pi halves, and 2 pi, you'll need to know the y coordinates. And the same thing when it comes up when we do cosine graphs. Okay, so let's keep in mind this chart right here, which again, you can say, man, that's a lot of memorization. And I would argue it's not much memorization at all. Hopefully it's a lot of sense as you're going around the unit circle. So what I would do is I would just quickly reproduce that chart. I had it going horizontally. We can have it going vertically. Actually, vertically sometimes seems to make more sense to people. So we got x, we got sine x. Our key points were 0, pi halves, pi, 3 pi halves, and 2 pi. And our y coordinates were 0, 1, 0, negative 1, down to 0. Okay, now it's a matter of figuring out what do these different things do to our graph. Well, the number in front, the amplitude, it makes the graph go up 2 and down to negative 2. What does it do? Well, the 2 affects the up and down. That's the y coordinate. So we're going to multiply the y coordinates by 2. And I'll have another chart later that will sum all these things up. So I come over here, and again, sine x, this is y equals sine of x. These are my y coordinates on the right. And I take all of these, and I multiply them by 2. Well, 0 times 2 is still 0. 1 times 2 is 2. 0 times 2 is still 0. Negative 1 times 2 is negative 2. And 0 times 2 is 0. So the amplitude, you're going to multiply your y coordinates by that amplitude. That will work every single time. Now the phase shift is moving things left and right. Left and right are the x coordinates. The right means you're adding on. And how much do we add on to our x coordinates? Pi. So now we come to our x coordinates. And to each of these x coordinates we add on pi. Well, the first one is easy. What's 0 plus pi? It's pi. The next one, it's pi halves. And we have to add on pi. So let's just have a little space here. So here's pi halves. Add on pi. This is like 1 whole. 1 is, if you want common denominator, is like 2 halves. So pi halves plus pi is going to be 3 pi halves. See if I can fit that in there, hopefully legibly. 3 pi halves. Pi plus pi now gives you 2 pi. 3 pi halves plus another pi, check your fractions, that will give you 5 pi halves, so 2.5. And 2 pi plus another pi gives you 3 pi. So once you've altered your coordinates, you come back to your graph. So I've got a graph here, got my y coordinate, got my x coordinates, and I put in my tick marks, except now I'll put in a couple more because this graph doesn't start till pi. So I label pi on my x-axis. I label 3 pi halves. I label 2 pi. I label 5 pi halves. And I label 3 pi. And the y-axis, look, it goes up to 2 and down to negative 2. So I come up to 2, down to negative 2. And it's just a matter now of plotting these points. So my point was pi 0. Graph that point. There's pi 0. It was 3 pi halves 2. Here's 3 pi halves 2. I should label this axis. It was 2 pi 0. 2 pi 0 is right there. It was 5 pi halves negative 2. 5 pi halves negative 2. And it was 3 pi back to 0. So 3 pi back to 0. Look, guys, you get a sine graph. Look, it goes up to 2, down to negative 2, and you picked up your whole graph and you shifted it to the right pi. You know these continue indefinitely, so you can easily continue your graph in both directions. But the main part I'm looking for is a labeled graph with my x-axis labeled. I want the y-axis labeled. And I'm looking for that kind of key part. What happened to my sine graph? It got shifted to the right pi, and now it goes up to 2 and down to negative 2. So that part in the green is the main part of what we're looking for on these problems. All right, let's give ourselves a little space here. Let's try one more. And again, this is going to take time. These are not easy. Let me give myself just a little more space for this guy. All right, so we've got 2/3 cosine of x plus pi halves. Similar to the first one, we have the same two numbers. Now our amplitude, oh my goodness, is only 2/3. And the phase shift, we always do the opposite. So it's pi halves, but we're going to the left. Okay, again, you might be able to see this in your head. Take a cosine graph, shift it to the left pi halves. Make it go up now, instead of 1 and negative 1, make it go up just to 2/3, down to negative 2/3. And it's entirely possible you're seeing that in your head. If not, look here at our cosine graph. Do you know what that looks like? Could you have taken that cosine graph and shifted it left and right? I bet you could. Could you make it go up to 2/3? I bet you could. If not, right here is what we're going to work with. And again, this will be better as we get more complicated problems with 3 or 4 things going on. This will make a whole lot more sense. I didn't need to change that. Let's put that away. And let's get our cosine graph. So let's start with our chart. And it seems like people prefer these horizontal charts. No, I'm sorry. They don't prefer those horizontal charts. It seems like they prefer the vertical charts. So I've got x, and now y is the same thing as the cosine of x. My key points are 0, pi halves, pi, 3 pi halves, 2 pi. My y coordinates, remember, are 1, 0, negative 1, 0, 1. All right. What does the amplitude do? Remember, you multiply the y coordinates. So let's take them all times 2/3. 1 times 2/3, 2/3. 0 times 2/3, 0. Negative 1 times 2/3 is negative 2/3. 0 times anything is 0. And 1 times 2/3 is 2/3. Not bad at all. All right, phase shift. Pi halves to the left. So now I have to subtract pi halves. All right, what's 0 if you take off pi halves? It would be negative pi halves. What's pi halves minus pi halves? 0. What's 1 pi minus a half pi? So 1 minus pi halves, 1 pi minus pi halves, you'll have a half left over. We'll practice these fractions. 3 halves minus a half is 2 halves. But guys, 2 halves is the same thing as pi. And 2 minus a half leaves you 1.5. And we typically write that 3 pi halves. So once you've redone your chart like this, let's sketch this graph. And again, this time we need a little bit to the left of the y-axis. Put our tick marks on. We'll label our x-axis. We start left of, here's our origin. So we start left, we have negative pi halves. We've got a 0. We've got a pi halves, a pi, 3 pi halves. That looks good. Then our cosine goes up to 2/3. So maybe we just want to say, look, put a tick mark and say, look, that's 2/3. Say, look, that's negative 2/3. Something like that. And now we plot our points. So we had negative pi halves, 2/3. Negative pi halves, 2/3. Looks good. 0, 0. Nice. Pi halves, negative 2/3. Pi 0, 3 pi halves, 2/3. And look at this, sure enough, you get a very nice looking cosine graph. What happened to it? Well, the amplitude dampened it. It only goes up to 2/3 and down to negative 2/3. And this right here shifted it to the left pi halves. So this completes our next 2 graphs. A lot to take in. We're going to take a couple days on this to get the hang of it. Again, if you're doing it intuitively, A-OK. But if you're making these charts, might even be a little bit better in the long run.